Sorry for the interruption. Here is an impurity defect is there. Observe this one here is an sodium and chloride. Sodium chloride atoms are there. Sodium I have written in the pink color, and then the chlorine is in the green color. But in the between of that one, instead of sodium, another element has been entered. That's called what? Silicon is entered, the strontium is entered, and another element is entered. So that one, what happens here? So if the molten NaCl containing strontium chloride, that's an sodium chloride is there, instead of sodium chloride, strontium chloride crystal is mixed. The site of the Na positive ion or Na plus ion replaced by strontium ions. This defect is called what? Impurity defect. Go for that one. Defect is very clear. Impurity defect. So in the same type of the sodium chloride solution, strontium chloride is entered. That defect is called impurity defect. Example is cadmium chloride and then silver chloride. Then we come to that another one is there, non-stoichiometric defect. I go for that one, the non-stoichiometric defect. What is meant by non-stoichiometric defect here? The stoichiometric ratio, that is the ratio of number of constituent particles disturbed. It disturbs the stoichiometric ratio, that is the number of the constituent particles. This is called what? Non-stoichiometric defect. So in this non-stoichiometric defect, there are two defects are there. One is a metal excess defect and metal deficiency defect. In metal excess defect, by anion vacancies, here we should know that one is very important. The one question may be asked, that one F centers. I want to make another video for this one, another diagram for F centers. I will continue this one. Please, after this all the videos, you go for F centers and some other important questions with diagram. F centers are there. F center means these centers are responsible for coloring properties. This is metal excess defect. In the interstitial site, the F centers will be arranged due to the cationic valencies by the anion vacancies. By anion vacancies, the vacancy will be formed. That center is responsible for the coloring center. That is called Forbengenter. Forbengenter means, Forben means color. The color of the crystals, the color of the elements, the color of the compounds is responsible by the F centers. That's in Forbengent center. I will tell you this one, another diagram. So this is about by anion vacancy. Just you listen that one. ಆನೈನ್ ವೇಕೆನ್ಸಿ ಹೇಗಾಗುತ್ತೆ? ಎಫ್ ಸೆಂಟರ್ಸಲ್ಲೇ ಆಗುತ್ತೆ. ಆನೈನ್ ವೇಕೆನ್ಸಿ ಹೇಗಾಗುತ್ತೆ? ಆನೈನ್ ವೇಕೆನ್ಸಿಯಿಂದ ಏನಾಗುತ್ತೆ? ಎಫ್ ಸೆಂಟರ್ಸ್ ಆಗುತ್ತೆ. ಎಫ್ ಸೆಂಟರ್ಸಿಂದ ಏನು ಪಾಸಿಬಲ್ ಇದೆ? ಕಲರಿಂಗ್ ಪ್ರಾಪರ್ಟಿ. ಸೊ ಇಟ್ ಇಸ್ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಫಾರ್ ದಿ ಕಲರ್ ಇನ್ sodium chloride, lithium chloride and potassium chloride. Again you come to that one, metal deficiency defect. If the ions are less, then that defect is called metal deficiency defect. This is iron oxide, iron sulfide and nickel oxide. Just you go for this one and again take that all the diagrams as possible. You go for that, the different things of the thing. Then I come to that one, clearly know that one. In this one, very important means Frenkel and Schottky defect. Here is an about dislocation defect. This is called what? This is not affected by that one. This is, and it will, the density will be affected in Schottky. It is in dislocation defect. This is called density remains same. Got it? So in the questions bandaga, you should be very careful the differences of that Frenkel and Schottky defect. 2 points will ಬರ್ತಿರಬೇಕು. So after this I come to that one, the electrical properties of solids, electrical properties and magnetic properties of solids. It is also the last content of that one. Just I come to that one, electrical property and the electrical properties of the solids. Observe here, electrical property in the sense conductivity. First it will comes under the conductivity. Electricity and the conducting maadu. All the solids do not conduct electricity with the same easy way. So the conductivity means passing the electrons, passing the charge through the different electrons. They're passing that one depending upon the magnitude of the conductivity. So understand the word about the magnitude. How much of the conductivity is there? Depending upon the conductivity, the solids are classified as the conductors. It depends upon the magnitude property. That's the magnitude of the conductivity. Depending upon the magnitude of the conductivity, there are three types. That's in conductor. First one is conductors. Conductors, the conductivity is 10 to the power of 4 to 10 to the power of 7 Siemens inverse. Siemens is a unit of the magnitude of the conductor. Then insulators. Insulators, 10 to the power of minus 20 to 10 to the power of minus 10 Siemens inverse. Same type semiconductors. Here is 10 to the power of minus 6 to 10 to the power of 4 Siemens. Here conductivity is more, and here is conductivity is no conductivity, and here is conductivity is less. But in this semiconductors, the different solids, how the different solids will come, that one. Here is about that one, semiconductors. What are semiconductors and how that one, the different types of the semiconductors takes place here. This is, I think it is the another one, last one. After this one I come to that one, another diagrams and the last concept of the solids. Here is about the semiconductor. Semiconductors means silicon and germanium considered called as a semiconductors. Semi, half, they do not conduct electricity completely, they conduct electricity partially. That's why they called as a semiconductors. In that semiconductor, you know that one the property, but here is about, this is also same question in the last 10th classes, but it is repeating. N type of semiconductors and P type of semiconductors. Dear students, it's very important that N type of semiconductors by one example. ಹೇಗೆ ಅಲ್ಲಿ ಎಕ್ಸಾಂಪಲಲ್ಲಿ ನೋಡಬೇಕು ಅಂದರೆ, ನಾವು ಕಂಡಕ್ಟಿವಿಟಿ ಫಾರ್ಮ್ ಆಗೋದು ನಮಗೆ ವಾಟ್ ಅಬೌಟ್ ದಟ್ ಒನ್, ದ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಂದ. ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸಲ್ಲಿ ಎರಡು ಎಲಿಮೆಂಟ್ಸ್ ಗ್ರೂಪ್ ತೊಗೋಬೇಕು, 15th ಗ್ರೂಪ್ ಆ್ಯಂಡ್ 13th ಗ್ರೂಪ್. 15th ಗ್ರೂಪಲ್ಲಿ ತೊಗೊಂಡಾಗ ಪೆಂಟಾವೆಲೆಂಟ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ಇನ್ 15 ಗ್ರೂಪ್ಸ್ ವಿ ಫೈಂಡ್ ಪೆಂಟಾವೆಲೆಂಟ್. In 13th group we find trivalency. So I come to that one. What are N type of semiconductors? So here just observe this point. When pentavalent impurities like A square P, in just one ನಾನು ಅಬ್ರಿವೇಷನ್ ತೊಗೊಂಡಿದ್ದೀನಿ ಅಷ್ಟೇ, ಬೇರೆ ಏನಿಲ್ಲ. ಆ್ಯಂಟಿಮನಿ, ಅರ್ಸೆನಿಕ್ ಆ್ಯಂಡ್ ಫಾಸ್ಫರಸ್. ನಮ್ಮ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ಗೆ ಹೀಗೆ ಇದೇ ಮಾಡಬೇಕಂತೇನಿಲ್ಲ. ಜಸ್ಟ್ ವಾಟ್ ಎವರ್ ದ ಥಿಂಗ್ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ದಟ್ ಒನ್. 5 means pentavalence, and then A square means 2 A's are there. First is antimony and arsenic, and the third one is phosphorus. Only the limited examples: antimony, arsenic and phosphorus. When pentavalent impurities like antimony, arsenic and phosphorus are doped with silicon or germanium, listen carefully. ಇಲ್ಲಿ ಡೂಪಿಂಗ್ ಮಾಡ್ತೀವಿ. ಡೂಪಿಂಗ್ ಅಂದರೆ ಏನಲ್ಲಿ, ಒಂದು ಎಲಿಮೆಂಟ್ ಯಾವುದಲ್ಲೂ ಇರೋಲ್ಲ, ಆ ಎಲಿಮೆಂಟ್ ಬದಲು ಏನಾಗುತ್ತೆ, ಸೇಮ್ ಟೈಪಲ್ಲಿ ಸಿಲಿಕಾನು ಜರ್ಮೇನಿಯಂ ಹಾಕಲ್ಲ. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಸಿಲಿಕಾನ್ we are applying antimony, arsenic or phosphorus in this silicon or germanium crystals. So that's called doping. The doping is a process where the increasing of the conductivity of the semiconductors. The process of increasing the conductivity of semiconductor is called doping. In 10th standard ನಿಮಗೆಲ್ಲ ಬಂದಿದೆ ಅದು, what is meant by doping ಅಂತ. ಸೊ ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ವಿ ಇಲ್ಲಿ, here we are going that one. The pentavalent impurities like antimony and arsenic and phosphorus are doped with silicon or germanium crystals. Then we are obtaining a semiconductor. Such semiconductors are called N type of semiconductors. Again the same thing we are getting that. What are P type of semiconductors? Here is also same. So the trivalence electrons, trivalence electrons like trivalence elements like boron, indium, gallium of 13 group elements, they are replaced in the germanium and silicon crystals. Then we are obtaining the semiconductors. Such semiconductors are P type of semiconductors. Again I go through that one. One formula ಇಟ್ಕೊಳ್ಳಿ, N5A square P. N ಅಂದರೆ N type, 5 pentavalent, antimony, arsenic and phosphorus. This is an N type of semiconductors. Very easy method. So I have been taught that one, by that one. Then I have been teaching also the same thing here. Then trivalence, bigger, 3 bigger, that's a P3 bigger itkonಡ್ರೆ ನಮಗೆ definition, you get the definition. Go through this one. This is one of the definition word for the P type of elements. When trivalent impurities like boron, indium, gallium and aluminum, bigger, boron, indium, gallium and aluminum are replaced in silicon or germanium, the obtaining semiconductors are called P type of semiconductor. I think now I come to that one, the last content of the this today's class, magnetic properties of solids.
ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ನಮಗೆ 1 ಮಾರ್ಕ್ಸ್ 2 ಮಾರ್ಕ್ಸಲ್ಲಿ ಎಕ್ಸಾಂಪಲಲ್ಲಿ ಕೇಳಿರ್ತಾನೆ. Just to go for, we have the magnetic properties. We know 3 earlier in the earlier classes: diamagnetic, paramagnetic, and ferromagnetic. So you just observe dia, feebly repelled by magnet. They do not they do not attract the magnetic materials. The materials which do not attract magnets called diamagnetic. Para, little, they have affinity with the little one with the magnetic materials. Now one ಮೊದಲು ಕಲ್ತಿದ್ವಿ ಫೆರೋ, ಮೋರ್ ಅಟ್ರಾಕ್ಷನ್. ಇಟ್ಸ್ ಅ ಸಿಂಪಲ್ ಡೆಫಿನೇಷನ್ ಫಾರ್ ಅರ್ಲಿಯರ್ ವಿ ಆರ್ ಟು ಲರ್ನ್. ಬಟ್ ಇಲ್ಲಿ ನಾವು ನೋಡಿದಾಗ ದಿಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ಯಾರೆಕ್ಟರ್, ಫೀಬ್ಲಿ ರಿಪೆಲ್ಡ್ ಬೈ ಮ್ಯಾಗ್ನೆಟ್ ಆರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ, ದಟ್ಸ್ ಕಾಲ್ಡ್ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್. ಎಕ್ಸಾಂಪಲ್ ನೋಡ್ಕೋಬೇಕು: ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್, ದೆನ್ ಬೆನ್ಸಿನ್ ಆ್ಯಂಡ್ ಟೈಟಾನಿಯಂ ಆಕ್ಸೈಡ್. ಅಗೇನ್ paramagnetic material, very para ಅಂತ ಹೇಳ್ಕೊಳ್ಳಿ. Paramagnetic material, when you are learning again you repeat paramagnetic materials, they are affected the little they show the little attraction, loses magnetic characters as soon as the field is removed. Very important. ನೋಡಿ ನಮಗೆ ಸೆಕೆಂಡ್ ಇಯರ್ನಲ್ಲಿ ನಮಗೆ, so the when that the knowledge has been improved, we have to take this definition. They lose the magnetic character as soon as their field is removed. Such magnetic materials are called paramagnetic materials. So here's an example is oxygen, copper and iron, 2 plus and then iron 3, ferric. Then come to the ferro. Ferro means more attraction. It's a permanent magnetic characters. Here these materials which shows the permanent magnetic characters even when magnetic field is removed. Even when magnetic field is removed, then it shows the magnetic field. That materials are called ferromagnetic materials. Example, chromium oxide. So then come to that another one, antiferro. This is just a different one is there. Antiferro, anti means opposite. They shows the zero net moment of the attraction. Example is MnO. They do not show that. Observe the beauty of the ferromagnetic substance. So that's how the word is there. Just observe that the 2 R marks are above and then 1 R mark is below, and then is then 2 R marks are above and then below. These are the parallel and the anti-parallel lines. Ferromagnetic shows both the parallel and anti-parallel lines. Then it possesses some magnetic property. That's called what? Ferromagnetic substances. Ferromagnetic. Example is Fe3O4. So this is about how that one the different the semiconductor and magnetic property. I tell you, dear students, both the conductivity and magnetic property depend upon the number of valence electrons. Number of valence electrons. If the valence electrons are more, the conductivity is more. If the valence electron is less, conductivity is less. Same in magnetic property also. If the valence electrons are more, the conductivity is more. Sorry, magnetic property is more. They shows the magnetic property. If it is less, they shows that one. And even in coloring properties also same. I think I conclude all these things by using this today's content. I think you can recall that one, all the type of the materials thing, that one we have learned today. Packing efficiency of simple cubic, packing efficiency of BCC, then FCC, then R value, A value, all the values. I think that one. Okay, thank you. Read well, get into more studies, get score more marks. Thank you one and all. And one request for the students and the dear parents and then the friends, those who observe this one, please share to the others and ask them to go through that one, and just to send you by subscribing it. Thank you.